The topic is computing partial derivatives algebraically. So let's do the first example. Let f of xy equal ln of x to the fourth plus y to the fourth. And let's find partial derivative with respect to x. Now since we have ln of a function u, to read the definition, partial with respect to x is right here. To find partial with respect to x of a function, you regard y as a constant and differentiate f of xy with respect to x. Alright, so what do we do? First, we need to use this formula. What's the derivative of ln of u? Is u prime over u. So in other words, this will be, let me write it here. Partial of ln of x4 plus y4 with respect to x is the same thing as, think of the inside is a u, so the u goes to the denominator, and you want partial with respect to x of x4 plus y4. Does it make sense? I'm using this property. Okay, what else? Now, to find the partial with respect to 4, think of y4 is a constant, so that would be, let me do it in two steps. That would be partial with respect to x of x4 plus partial with respect to x of y4 divided by x4 plus y4. Now, partial with respect to x of x4 is 4x cubed plus partial of y4 with respect to x is 0 because it's regarded as constant. And then this will be x4 plus y4 and you're done. So it's 4x cubed over x4 plus y4. Just disregard the 0. I don't have space. Alright, now same way we need to do partial with respect to y of ln of x4 plus y4. Using this property, this is the same thing as partial with respect of y of the u, which is x4 plus y4, divided by x4 plus y4. Now, same way, that would be partial with respect to y of x4, plus partial with respect to y of y4, x4 and then y4, divided by x4 plus y4. Now we know that this is going to be 0, so you have a 0 plus 4y cubed, right, over x4 plus y4, and we're done. Again, disregard the 0, I just don't have space. Alright, now let's do next example. Alright, we're doing partial with respect to x. So we have to think this as a product rule, right? So think of this as some function f. Don't confuse it with this f. This is some function g. So f prime g, let me write it here. Fg, we're using this property. Fg prime is equal f prime g plus g prime f. So see how much space I have. So this will be equal, write it here, this partial will be equal to partial with respect to x of ex times sine of x minus 2y plus partial with respect to x of sine of x minus 2y times e to the x. So let's do one thing at a time. Partial with respect to x of ex is x. Let me write ex, derivative of ex, we know it's ex. So this will be ex times sine of x minus 2y. Now here I have a problem. I need to use this property. Sine of a function is equal derivative of that function, u prime, times, remember this u is a function. You have to take the derivative of that times cosine of u. In other words, think of this as u, right? This is my u. So you need partial with respect of x of that u. This is like chain rule. Times cosine of u. So cosine, let me do it this way. Cosine of u. And don't forget the e to the x. Where do I put it? Let's leave it here for now. Let's do this so we don't confuse the stuff. Alright, this is going to be equal to ex sine of x minus 2y plus, now remember this is partial with respect to x, so it's going to be partial with respect to x of x, which is 1, minus 0, right? 2y is a constant, so partial with respect to x of 2y is 0. I'm just not going to write it down, so it's going to be just 1 times cosine of x minus 2y times ex. I'm going to write the ex here. And I'm done. Well, let me rewrite it. You need to get rid of that 1. So ex sine of x minus 2y plus e to the x cosine of x minus 2y. So this is the answer. Now we need to do partial of f with respect to y. So same thing right here. So this will be, well, now we're doing partial with respect to y, so it'll be a little bit easier because remember ex now is a constant. So you could take it outside and just do partial with respect to y of sine of x minus 2y. Right? Now again, I need, using the same property here, let me rewrite it here. This will be ex. I need to do partial of the inside of a u, right? U prime cosine. So partial with respect of y of u, which is x minus 2y. And derivative of sine is cosine. So cosine of u. Right? Try not to skip steps. There's a chance you can make easy mistakes here. Now this is ex. What's the partial with respect to y of x minus 2y? Remember, x is a constant, so that's a 0, so it's a minus 2. Times cosine of x minus 2y, and this is just minus 2 ex cosine of x minus 2y. And that would be the answer. So we didn't have to do product rule because e to the x is considered a constant. Alright, so let's do a last example. Again, partial of f with respect to x. Now we have to use quotient rule. Let me write it here. F over g derivative will be f prime g minus g prime f over g squared. So this is going to be equal partial with respect of x of the numerator times denominator minus partial with respect to x of the denominator times numerator. Everything over the denominator squared. Alright, this is going to be equal to, now you can probably do shortcuts. Partial with respect to x. See, partial with respect to x of x squared will be 2x plus 0 because y squared is a constant, so we're going to ignore it, times x4 plus y4 minus, and again partial with respect to x of x to the fourth is 4x cubed plus 0 because y to the fourth is a constant, then times x squared plus y squared. All of this over x4 plus y4 squared. Now this is going to be equal to, I'm going to distribute, this will be 2x5 plus 2x y4 minus 4x 5 minus 4x cubed y2 over x4 plus y4 squared. So let me see if anything can be simplified. Yes, 2x5 minus 4x5 will be minus 2x5. What else? That's it. Plus 2x y4 minus 4x3 y squared. Everything over x4 plus y4 squared. Alright, now let's do partial of f with respect to y. I mean, same thing. We have to use quotient rule, which is right there. So we need to do partial with respect to y of x squared plus y squared, right, times x4 plus y4 minus partial with respect to y of x4 plus y4, all of this times x squared plus y squared, everything over x4 plus y4 squared. Now this is going to be equal to, again, partial with respect to f(x) squared is 0, but partial of y squared is 2y, 2y plus 0 is 2y, so that would be 2y times x4 plus y4 minus, then partial with respect to y of y4 is 4x cubed, 4y cubed plus 0, so it's 4y cubed times x squared plus y squared over x4 plus y4 squared. Then last step, I'm going to distribute. That would be 2x4y plus 2y5 minus, distribute here, 4x squared y cubed minus 4y5, everything over x4 plus y4 squared. And then the last step, let me write it here. Can we simplify? Yes, we can simplify these two. So this is going to be 2x4y minus 4x squared y cubed. 2 minus 4 is minus 2y5. And then all that over x4 plus y4 squared. And that's it.